Hey everyone, and welcome to the extension activity. We're going to be finding the surface area of prisms using Pythagoras theorem. So, whenever you see a right angled triangle, think Pythagoras theorem, okay? So here is an example of that. Okay, so it's find the surface area of the prism, and it is a triangular prism. So obviously, if the triangle of the triangular prism is a right angle, we can use Pythagoras theorem if we have some unknown sides. Okay, so our first step for any prism is to find the identical sides. Okay, area of identical ends. Okay, in this case, we need the area of the triangle. So the triangle at the front, which is this one here. Okay, we are going to do area equals a half times base times height. Okay, so our base in this case is the bottom part, which is 8. And our height is 15, which is the same as the one at the back. So that's 15. Bring that one up, that's 15 now. So our height is 15. Now we substitute that in, half times 8 times 15. And that is going to be half times 8 times 15. That is 60 centimeters squared. Okay, so that's step 1. Step 2 is you could use either method. I'm going to use the perimeter method. Find the perimeter of the triangle or the front face. Okay, so what we need for the perimeter is we need all 3 sides. However, we're missing one of the sides. We're missing this side here. So what we need to do is we need to use Pythagoras theorem to find that side. So I'm going to do a quick sketch of that triangle and draw it over here for us to have a look at. So this side is 15 centimeters from before. This is 8 centimeters as given. And this side, we don't know what that is. So we're going to call it x. Now, x is the hypotenuse of the triangle. So we just use straight Pythagoras theorem, which is x squared equals 15 squared plus 8 squared. Okay, so 15 squared plus 8 squared, if you put that in the calculator, you get 289. That's x squared. X equals the opposite of squared, which is the square root of 289. And the square root of 289 is 17 centimeters. Okay, now that we have the unknown side, we can find the perimeter. So the perimeter equals 8 plus 15 plus 17, which equals 8 plus 15 plus 17, which equals 40 centimeters. Okay, so last step, step 3, we now find the area of the connecting sections, area of connecting sides. Or you do the left side, the right side, and the bottom side if you're using the other method. And to do this, you got to times by the depth. So the area equals 40 times the depth, which is, I'll change the color to green, which is this section here, which is 12. So how far back it's going. Okay, so 40 times 12 equals 480 centimeters squared. Okay, we're not quite done yet because we need to find out the total surface area. Okay, so the total surface area is the area of the front and the back, the identical ends. Okay, so this is only one of them. We've got to times this by 2. Okay, so we have two triangles, plus the connecting sections. Connecting sides, or 4 rectangles. Oh, 3, sorry. Three rectangles. Okay, so our triangles, that is going to be 60 times 2 from our previous step 1. Then we're going to add the connecting sections, which is 480. Okay, so the total surface area is 600 centimeters squared. Okay, so have a go at those extension questions. If you have any questions, please come to Jamboard. I will be on from 11 to 12 o'clock. Good luck with the questions.